Have you ever seen a math problem that looks completely harmless, almost childish, and yet somehow manages to confuse grown adults? Today's puzzle did exactly that. It was presented as a question for 10-year-old students, but when it appeared online, adults debated it, overanalyzed it, and many even got it wrong. The question seems simple. What is the length of the yellow ruler? That's it. No calculus, no advanced algebra, just 3 rulers inside a box. And yet it hides a beautiful lesson about how we think. Imagine a box that measures exactly 18 centimeters, from left to right. Inside this box, 3 rulers are placed in a staggered arrangement. A yellow ruler, a blue ruler, and a green ruler. The yellow ruler starts at the left side of the box. The blue ruler is positioned slightly to the right of the yellow ruler, and at one point it extends 3 centimeters beyond the end of the yellow ruler. The green ruler starts 2 centimeters to the right of the blue ruler. We are also told something important. The blue ruler is exactly 1 centimeter shorter than the green ruler. With all of this information, and knowing that the total span across the box is 18 centimeters, we are asked to determine the length of the yellow ruler. At first glance, many adults approach this problem with algebra. Let the green ruler be x centimeters long. Since the blue ruler is 1 centimeter shorter, its length is x minus 1. From there, we start subtracting and adding distances, accounting for the 3 centimeter extension and the 2 centimeter shift, carefully tracking every segment. The expressions begin to grow. Terms cancel. We distribute negatives. Eventually, something interesting happens. The algebra simplifies dramatically. The x terms cancel out entirely. What remains is not a complicated expression, but a clean number. On the right side of the box, we effectively account for 3 centimeters from one extension and another 3 centimeters from the alignment relationships. Altogether, that makes 6 centimeters that are not part of the yellow ruler. Since the entire box is 18 centimeters, subtracting 6 leaves us with 12 centimeters. The yellow ruler must measure 12 centimeters. But here's what's fascinating. The algebra disappears. The variables cancel. The solution does not depend on x at all. That's a clue that perhaps algebra was not the intended path. There is a simpler structural way to think about it. Instead of assigning variables, we can mentally trace the journey across the box. Start at the left wall and move across the yellow ruler. Then move forward 3 centimeters. Then account for the blue ruler's length in reverse. Move forward again 2 centimeters. Then move forward along the green ruler. When you simplify that entire journey, something elegant happens. The subtraction of the blue ruler and the addition of the green ruler, which is just the blue ruler plus 1 centimeter, cancel each other out except for that extra 1 centimeter. In the end, what remains across the box is the yellow ruler plus 3 centimeters plus 2 centimeters plus 1 centimeter. That totals 6 extra centimeters beyond the yellow ruler. And once again, 18 minus 6 equals 12. There is an even more intuitive way to see it. Imagine physically sliding the blue ruler 2 centimeters to the right so that it lines up perfectly with the green ruler. Now they share the same starting point. Since the blue ruler is 1 centimeter shorter than the green ruler, their endpoints differ by exactly 1 centimeter. Now slide the blue ruler back to its original position. When you do that, you create a 2 centimeter gap on the right. Combine that 2 centimeter shift with the 1 centimeter difference in length and the original 3 centimeter extension, and once again you uncover the same total extra distance of 6 centimeters. The remainder of the box must belong to the yellow ruler, and that remainder is 12 centimeters. What makes this puzzle powerful is not the arithmetic. It is the psychology. Adults often overcomplicate problems because we assume complexity. We jump to algebra, introduce variables, and build equations. Children, however, often visualize and experiment mentally. They slide objects in their minds. They notice symmetry. They see cancellation. This puzzle rewards flexibility more than formalism. It teaches us that sometimes structure matters more than symbols. The numbers in the problem, 3, 2, and 1, are not random. They combine neatly into 6, which is precisely the difference between the total box length of 18 and the final answer of 12. That harmony is not accidental. Well-designed mathematical problems often contain internal balance. When we slow down and observe the structure instead of rushing to compute, we uncover that elegance. In 2026, when AI tools can instantly compute equations, the true skill is not mechanical calculation. It is interpretation. It is recognizing patterns, cancellations, and symmetry before writing down formulas. AI can compute quickly, but human intuition recognizes balance. And balance is at the heart of mathematics. So, yes, the yellow ruler measures exactly 12 centimeters. But the real lesson of this puzzle is deeper. Think before calculating. Visualize before formalizing. Look for structure before building equations. Mathematics is not just about getting the answer, it is about seeing why the answer must be what it is. This is MathWhisperer, where we don't just solve problems, we understand them. And I'll see you in the next episode.